Okay, so the next step here is a little more involved. It's going to be not quite as exciting because we're looking at lists, and I'm spending a lot of time on this, and it's a little bit more of like a best practice because in reality, in many cases, when you have what's called a null item that shows up in your list, it'll still work. It just won't calculate that number, but or won't calculate that index, right? Because there's nothing there, so it just skips it. Um, or rather, it doesn't skip it. It just calculates it as a further null value as you get down the list. So what happens is when you have null values, once you have a different calculation and you try to blend two lists. So let's say, for instance, we wanted to change the height of each one of these, but we wanted to do it based off of a distance of how far each of these points is from an attractor point. That would be an instance where we have 8 numbers that go into 7 spots. So, really it's just going to stop the list one short. But then if we try to use these 8 numbers later, when we only have 7 values generated off of this, it's going to, create complications. Or rather, vice versa. If we try to take these 7 numbers and plug it back into that, we're going to be one short. So, best practice is to delimit the number of values wherever possible. So what's going to happen here is if I'm mapping this bridge, I'm going to map a line, right? So and I'm going to very simply just do this with lines right now. I'm going to do the skeleton, then we'll worry about the surfaces. But if I'm going to map a line, I'm going to go from the top point to the bottom left point. And I'm going to go from the top point again to the bottom right point, right? That makes sense, you would think, because on the top rail, you have 2 values that protrude from every point, versus on the bottom you have 1 value from a couple, but you have 2 from most of them. So there's less variability on the top. So let's do that. Let's take a look at what it actually means to do that. So I have my top chord points right here, and I'm going to actually map it using the line command. So under curve and primitive, I'm going to use line. And so the key here is going to be if I want to map a line from the top to the bottom, I pretty much want to take my points on the bottom, which are going to be these right here, and my points on the top and blend them together. You would think that works, but it doesn't. So the first issue is that they don't actually match in terms of their organization. So the list that came out on the bottom is a flattened list. So I would actually have to graft that into matching values. And then I get this. So why do you think this happens? Anybody? It's a product of the difference in numbers in each of the lists. So if you think about it, basically what's happening, the index value of 0 is mapping down to the index value of 0. And it keeps doing that for number 1, number 2, number 3, number 4, number 5, number 6. And then there is no more, there are no more points for it to map down to the matching list, which has a number 7. So it takes number 6, number 8. So it takes number 7 up here, and it plugs it down into number 8 as well. So it just repeats that list, the last item in that list on the top chord. So what we have to do is break that bottom list so that we create one list that has index values 0 to 7, and then we have another list that has index values 1 to 8. And then we plug them in and it'll be nice and clean. So 7 values in both lists, or all 3 lists, I should say. So let's take a look at that. In fact, I'm going to disconnect this until we get there so it doesn't look confusing. So let's go to set and list. And I'm going to use, let me figure out which one I want to use. Is this going to do an index to split? Yeah. Yeah, let's do it with this. So this one is saying that it's going to split a list into separate parts based off of an index value. So that's important because we're essentially going to have to break the list at both a value of 1 less than the maximum length of the list, and then 1 more than 0, right? So just a value of 1. And we're operating, I'll slide this down, we're operating on this list of points down here. So let's kind of move it over there. And so the key here is going to be that relationship of 1 less than and 1 more than. So I'm going to start with the value of 1 less than, because the first list I want is going to start from 0 and end at 7. So in order to generate that, I'm going to put in my points list here, and then I just need to figure out the number that is 1 less than the maximum length of points that I have here. And so we can do that using list and list length, like that. And if you're so inclined, you can use an expression. But in this case, I'm going to try and make it a little bit more visible, because I think the expressions we have a tendency not to remember that they're there. So I'm going to make it actually visible here. I'm going to go up to Math and Operators, and I'm going to do a subtraction of 1. List length minus 1. So the list length is 8, minus 1 gives us a numerical value of 7. So this split list gives us 7 values here and 1 value there. And that 1 value is the point that is 100 feet away from the origin, right? Makes sense. That's exactly what we needed. Now we have to do the other one. And the other one is going to be a copy. So let's copy it down. That's slightly different. So in this case, we don't need to do 1 less than the maximum length. In fact, we only need to do 1 more than the first index value, which happens to be the number 1. So I can theoretically just take all of that and plug the 1 in here, and then we'll check it out here. So now we have 1 index value, right? So index item 0 gets split, and then down here we're starting at the new index item 0, which actually was index item 1 in the previous list. How confused are you? Okay, well that's good. So then here's the key. Instead of plugging it in down there, we're going to have to plug in a line from the top chord to our first list, and then the top chord to our second list. So I'm going to put my geometry up here, and then I'm going to plug my first list in, and make sure that you pick the correct output. So A is the first partition of this list. So that's the one that has my 7 values. And again, that's going to have to be grafted. And just as a rule of thumb, guys, wherever possible, I try my best to graft on the output. Do any of you know why? Rather than the input of the line, why I put it on the output? So that I can visually see that it's a grafted list. Right? Because if I put it on the input, all I have is this little tag that tells me that that list is grafted. Okay? But if I do it this way, as long as I can, right? You can't always do that, but as long as I can, I'll know that that's a grafted list. Okay, and then copy and paste this and replace the connection. And remember that this one is not going to be the A output, because we took the first item and we threw it out. We're going to take the B output here and plug it into B. And that, again, should be grafted. Voila. What do you think? Awesome? Okay, so one more thing I want to throw in here. The cool thing about doing this particular exercise this way is that it automatically generates our endpoints to map our top chord. So if I take my line and I copy it up to the top, and instead of these connections here, so let me disconnect them. Instead of these connections here, I use the lone point. Oh wait, no, that's not the top chord. Crap, never mind. I was thinking of something else. Let's see. Yeah, so the top chord is going to be a product of this list. And so you're going to want the first and last item of this list. And so essentially you can take this value here and copy it down to that one. Sorry, I screwed that one up on you big time. But just replace the geometry value into these lists. Actually, sorry. Do it this way. Use a param for a points list, because these are all grafted into separate groups. So use a param and then flatten the list. And then plug it in. Do you all understand why I did that? Yes? No. Okay. So the reason that I did this is because what I'm doing here is I'm reading a list of items that have index values 0, 1, 2, 3, 4, 5. If you have a grafted list, like these values up here, they're coming out as groups of index values of 0, which means they don't have an index value of 1, 2, 3, or 4. They're not flattened. They're grafted into separate branches of data. Okay, so down here we have to flatten it so that it reads as a list like this, so that we can use it to extrapolate our 0 and our 6 value to draw a line for. So the result, everyone, is that now we can take a curve, primitive line, and instead of the A and the B value, we use the inverse, right? We use the culled out front end point and the back end point. Yeah. So the front end point would be the A here, and then the back end point would be the B here. And that gives you your curve. So let me clean this up for you all a little bit so that it's a little bit more readable. What questions do you have? All right. So I'm going to get you all caught up before we move on.